So we're going to create a very simple class. We're going to call it a box, but the class will have no data type to start with. The class itself is a data type, but within class there will be certain places which I'll say this particular region will get its data type during runtime. And those regions will be populated by their data types during runtime. So the entire class is complete, but those data types will going to be populated during runtime. So let's create this class first so that you can see how we create a class, a generic class. We're going to call it a box with a main method. And this is a box class with the main method. Okay? So what we're saying is the box class will have a generic type of T. That means wherever the letter T appears as a data type, that is controlled by the user. So I want one of the members of the class to be of type T. So the member of a class, its data type is not decided until the user makes a call. And then I'm going to add some methods here, and you can see that the T can now be used as a data type for a method call, member parameter. And as you can see, we are using this dot member, which refers to the member from line number 4, and the member on the other side of equals without this refers to the parameter. This is something that we learned in Java 1. Similarly, you can use the T type as a return value, like get member. So you return a member where the data type of the member is only known during the runtime. So we created a very simple class. One member, one getter, one setter. Now in the main, we will going to treat this class to be a class of different types. So we'll say box. I want you now to be treated as a box of integers. So I want it to be an int box. So all of a sudden, the box now acts like a box of integers. So the T on line number 2 during runtime, now because of that line, will act like, for that particular line, it will act like an integer. Okay? So now I can say int box dot add. So now I'm calling the add method, and I'm saying I want to add a number 100. And system.out.println value is, and now I'm displaying int box dot get member. So now we're going to return the value of the member. So I'm able to set the property and return the property. When you run this, you get the value equals 100 back. Okay. Now, just so that you can see that each of these will be maintained in their separate memories, I'm also creating another object of type box called string box. So I have two instances of box type in the memory. One is of type string and the other one is of type integer. To the string box, I'm going to add Sam. And to the integer box, I add 100. So now I'm changing my output to this. Name is sbox.getMember. Score is intbox.getMember. So now the same class is being used to generate both values. So one of the things that I could see over here is that instead of me having to create a class with two properties, one for name and one for ID or a score, I can just create a class with one member, and in the main I can create as many instances of the box type as I would like. Similarly, that one member that I have created up there, I could actually create an array of members. So this could actually be an array. This guy could be an array as well. So each instance of the box type will actually generate array members. So I can have a list of names and a list of their scores. So instead of me creating this entire structure within the class, I can do it from the main, where the class will be much simpler. So that basically is an example where you can see that how a generic class can be used.